Welcome to another episode of Explained by AI. Today we're going to be doing a deep dive into Starlink and whether this satellite internet dream can truly connect the entire world.
Yeah, it's a bold vision.
Yes, it is.
I mean, there's no doubt about that. But
Yeah.
the reality is that bringing high-speed internet to everyone, especially in these densely populated areas, faces some pretty serious technical hurdles.
Yeah, so we're trying to squeeze the entire internet through like a tiny little pipeline.
Right.
I was reading that Starlink relies on these very specific frequencies, these Ku and Ka bands.
Yeah.
What exactly are those and why do they matter so much?
So think of those as like specific lanes on a highway, right?
Okay.
Ku and Ka bands are portions of the electromagnetic spectrum that are really ideal for satellite communication.
Gotcha.
They offer this really good balance of signal strength and resistance to atmospheric interference.
Okay.
But just like any highway, these bands have a limited capacity, right?
Right.
Like a finite amount of data they can carry.
So even if we had like a zillion Starlink satellites up there, they'd all be bottlenecked by these frequency limitations.
Exactly, especially in cities.
Yeah. Like downtown somewhere.
Imagine you're trying to download a large video game in a packed apartment building where everybody's on Starlink.
Oh my gosh.
The source material indicates it's like 200 to 400 times less capacity than what we need.
Wow.
It'd be like trying to stream a movie through a dial-up connection.
Oh no.
Oh.
So how many people can a single Starlink satellite actually serve at once?
Well, for a decent experience, it's estimated to be around 20 users per square mile.
20. But cities have thousands of people crammed into each square mile.
Right.
That doesn't sound very scalable.
Well, and the math gets even more daunting when you consider the global population.
Yeah.
To give just 20% of households a Starlink connection, we would need over 10 times the planned 42,000 satellites.
Oh, wow.
That's a mind-boggling number. And we haven't even talked about the practicalities of like launching and maintaining such a massive fleet.
Plus, cramming that many satellites into orbit just sounds like a recipe for disaster.
It is.
Isn't there a huge risk of collisions?
Absolutely.
And creating even more space debris?
It's like trying to navigate a crowded parking lot with blindfolds on, you know?
Oh, gosh.
The more objects we put into space, the higher the chance of collisions. Which could create a cascade of debris that makes space travel incredibly dangerous.
Right. All those satellites, all that risk, it must come with a pretty hefty price tag.
Yeah, that's another major hurdle.
Great.
Launching and maintaining a constellation of that size, plus providing the ground equipment for users, is astronomically expensive.
Yeah.
Making it affordable on a global scale would require some truly groundbreaking cost reductions.
So Starlink might be great for connecting remote areas.
Right.
But blanketing the entire world with broadband. That seems like a much tougher challenge than we initially thought.
It is.
Do you have any topic that you would like to have explained? Drop it in the comments.